set of simultaneous equations that we know. And what we have done up till now in 12, those were all the problems related to maximum 3 by 3. We never came across 4 by 4. And till 3 by 3, we even have a method called as using determinants. What is that method called as? Consistency. Inverse matrix is one concept, yes. Cramer's rule is another, that is using determinants. So we had those methods, but all of them are likely to fail here. Because what is happening, even to find inverse, we will have to do lot of things. So the method that we study over here, first of all, we don't know whether it is consistent or not. We are simply not aware of whether it is consistent. So this thing you have studied, that we can write the set of simultaneous equations in the form Ax equal to. Right? So it will be written as obviously 2, 1, minus 5, 1, then 1, 3, 0, minus 6, then 0, 2, minus 1, 2, 1, 4, minus 7, 6. x1, x2, x3, x4, and the right hand. 8 minus 15 minus 5 and 0.
So we write it in this way. Now, whatever you have studied earlier, is anything of our help? Because if it is Cramer's rule, it will be delta x upon delta. So delta will be mod A. Finding 4 by 4 mod A will be difficult. Or is there a way to find mod A also in a faster way? Okay, or anything else? Row and column transformation. So what he is suggesting is row and column transformations. The word he has used is row column transformations, not column, because if you add this to this, the meaning changes. When these are system of linear equations, that is first degree equations, you can add equation to equation. You cannot add variable to variable. So we are not allowed to perform column operations. We can perform only row operations. Okay, so we agree that we will be performing row operations, and what should we do with them? Bring zeros and then proceed. Okay, so normally we say that if this element is there, using it, we should be making 1, 2 and 3 elements 0. It is row subtraction that we used to do something like it is 2x plus 3y equal to 5 and minus x plus 2y equal to 1. So we used to say that it is first row plus twice second row, so x will vanish and we will get value of y. Something like that only we should do. We never did something like 2x plus 3y. इसमें ये add करके नहीं किया हम. Right? Then the variable changes. The value of the variable changes. So no column operations, only row operations. And whatever we are doing here is to be done to eliminate x1 from all the rest of the equations. So one thing is it could be r2 minus twice r1. So this will be 0. ये तो already 0 है ही. Then r4 minus twice r1. But this will increase our calculations. So we can very well arrange the equations because we see 1 over here. Okay, so instead of going into half, I can always write the equations as 1, 3, 0, minus 6, and for the time being I am putting even this because operation is to be performed on constant also. Then so I am performing something like r12, then it is 2, 1, minus 5, 1, 8, then it is 0, 2, minus 1, 2, minus 5, and 1, 4, minus 7, 6, 0. And we continue in this manner. And obviously our operation will be r2 minus twice r1, r4 minus r1, and we will get this 0. So first row is now locked. Are you getting me what I am saying? Because these three are now zeros. Now using this element, 2 element, I should be making these two elements 0. अभी तो नहीं कर सकते because this is going to change now. Because when you perform R2 minus twice R1, this will be 0, and 1 minus 6, it will be minus 5. That minus 5 is of no use to us, because then it will be R3 minus 2 by 5, or R3 plus 2 by 5 times R2. So your calculations will increase. So you can play some trick in between. This is minus 5 and this is 4. So you can add R4 to R2. So this will become minus 1, and then making it, you make these two zeros. So these two will be blocked. Row 2 is gone. Then use 3 element, make this 0. Okay, if it goes well and you have some value over here and some value over here, the last equation will appear as 0x1 plus 0x2 plus 0x3 plus something x4 equal to some 4, something. So you can very well find out x4. Right? So we got one value. By chance if we get both as zeros, then 0x4 equal to 0. तो उसका कोई मतलब ही नहीं है, because we can't determine x4. In that case, we will say that, what should we say? Can we find the solution? इस केस में ऐसा नहीं होने वाला, but I am just asking you. If the entire last row, these 4 elements turn out to be 0, so something 0 equal to say value 4, so we will say these equations are wrong. क्योंकि 0x1 plus 0x2 plus 0x3 plus 0x4 equal to 4, ये तो हो ही नहीं सकता. It has to be 0. अगर वो 0 है तो we will still say that the equations are consistent. But then we can't determine x4. And if we can't determine x4, we can't determine x3 also. So we can assume that let x4 equal to 1. If we do that, then the very previous equation will contain only x3 and x4. We can substitute x4, जो हम पहले करने वाले हैं. We will get x3. Then x3 and x4 we will substitute in this, we will get x2. And x2, x3, x4 we will substitute in first, and we will get x1. So it is what we call it as back substitution. But when the entire last row comes out to be 0, we will have to comment on consistency. It is still consistent, but it will have infinite solutions, because whatever value x4 takes, accordingly x1, x2, x3 will take the values. So we assume over there that let x4 equal to t, and we find everything in terms of t. Instead of taking it as 1 or 2, we will take it as t, and x1, x2, x3, x4, they will be in terms of t. Fine, you assign the value to t, those 4 values will satisfy the equation. So equations are consistent. If we get these 4 as zeros and this is non-zero, we will simply say they are inconsistent, because we will never find such a value. So we have word consistent, we have inconsistent, they are inconsistent, and then but consistent and infinite solutions. You got the wording? Inconsistent, there is no solution, and consistent and unique solution, that will be this case. Right? Involves lot of calculations, and calculators won't help. Right? So you will have to simplify yourself. You will have to make the convenient positions of these. At the last moment, probably we will do some. This is pretty simple problem, but we have even the problems where the answers are 1 by 24, 7 by 12, and something like that, and we are not used to that up till 12th, because whatever problems we had, we know that the solution is going to be अच्छा दिखने वाला होगा, right? यहाँ पे नहीं होते, they are bad, and we are not sure कि ये solution सही है कि गलत है. The only choice that we have is substitute in one equation. If it satisfies, done. And don't substitute in the first one. Original equation में substitute करना है, ना कि reduced. क्योंकि reduction तो आप कर रहे हो. Making this lower triangle 0, the wording is, that is first step, and back substitution is second. Got it? करोगे? Follow your technique. I suggest that take the diagonal element and make these 3 0. So for me, the step will appear to be 3 things at a time. R2 minus twice R1. R3 के लिए कुछ नहीं करना है, R4 minus R1, and the operation is to be performed even on the constant. Then as if first row is not there, we will start from 2 2 position, make it conveniently 1 or minus 1, and using that we will perform these two operations. Then 3 3 and then down 1. Should I do this problem? Let me complete the first one, right? So once you have taken down the problem, others you can proceed. I have told you the procedure. Those who are okay with it, they can proceed, but I will complete first problem. So when we do this operation, first row remains as 1 3 0 minus 6 minus 15. It is R2 minus twice R1, so it will be 0 minus 5 minus 5 minus twice R1, so it will be 13, and minus twice R1, so it will be 38. This row remains 0, 2 minus 1, 2 minus 5, and last row it is subtraction, so it is 0, it is 1, and then it will be minus 7. When you subtract, it was 6 plus 6, 12, and when you subtract, it will be 15. Then I will perform something like R2 4, because 1 is already there. So it is 1 3 0 minus 6 minus 15, 0 1 minus 7 12 15. Then it is 0 2 minus 1 2 minus 5, and 0 minus 5 minus 5 13 38. It will be R3 minus twice R2 and R4 plus 5 times R2. 1 3 0 minus 6 minus 15, 0 1 minus 7 12 15. Then it is 0, this will be 0, subtracted twice, so becomes 13, subtracted twice becomes minus 22, subtracted twice becomes minus 35, 0 added 5 times 0, added 5 times becomes minus 40, added 5 times 73, added 5 times 75 आणि 40 113. This is something which was not happening in 12th. That we are subtracting and numbers are getting increased. But क्या करें अब? What do we do next? करना तो वही है. We want to make this element 0. And I can clearly see that there is a possibility of getting a root like this is minus 1 and this is plus 1. I can see it. हे काय यांची बेरीजच होते रे 35, यांची बेरीजच 113 होती है. But we can't say कि हाँ अब मिल गया. You will have to make this 0. So how you can do it this way? I am going to do one trick in between. It is R4 plus 3 times R3. So I will get 1 and then I subtract. सोपं पडेल ना. and otherwise the step should be R4 plus 40 by 13 times R3. This is the appropriate step. Got it? When nothing can be taken common, we are just helpless either to carry on with this or this. I continue with this. So one step increases, but that is okay with me. I won't write everything. I will simply write the last one, 0 0. When this is 3 times added, it becomes -1. This is 3 times added, so 7, yeah, -66 plus 73, and this is 3 times added, it becomes 8. 70, 105, 8, yeah, 8. And the next step is R34. So it is 1 3 0 minus 6 minus 15, 0 1 minus 7 12 15. Then it is 0 0 minus 1 7 8, and it will be 0 0 13 minus 22 minus 35. And it will be R4 plus 13 times R3. 1 3 0 minus 6 minus 15, 0 1 minus 7 12 15, 0 0 minus 1 7 8, 0 0 0. There is a 91, right? So what is the value? 69. And plus plus, yeah, and here again 69 or minus 69, 69. Okay, and so now we say back substitute. We have 69 x4 equal to 69, therefore x4 is equal to 1. And we go to the previous equation. So it is minus x3 plus 7x4 is equal to 8. So minus x3 plus 7 is equal to 8. So x3 is equal to minus 1. And go back. Right? And for this entire problem, we will have how many? 8 to 10 minutes max. So that is one more problem. The calculations should be correct, answer should be right. No marks are given for the steps. If your final answer is right, he will check what is the procedure that you have followed. So he won't check each and every step, but at least he knows, okay, how the things should happen. If one has proceeded with that previous step of making this minus 1, then it should be 69 69 for everybody. And if you have followed that 40 by 13 method, then that answer. So examiner knows that. So आपको वहाँ तक पहुँचना ही पड़ेगा. You can't just say 68 68 and 1 आ गया करके. They know that engineers are clever. So they do check the correct positions of it. May not each and every calculation, that is true. Right? Should we try one more? And it is simply the method. Intelligence won't help. Only calculations and time. 2 parameters. Right? And we don't have time to correct. So it is always better to write the things side by side. What you are doing. Matlab calculations also. Like here it was something like that we were doing, like minus 35 plus 8 times 13. You do it. So you know what you are doing, right? 4 into 2 na kalyu, and something like this we will have to. So take this second problem, 2x1 plus x2 plus 5x3 plus x4 is equal to 5. x1 plus x2 minus 3x3 minus 4x4 is equal to minus 1. 3x1 plus 6x2 minus 2x3 plus x4 is equal to 8, and 2x1 plus 2x2 plus 2x3 minus 3x4 is equal to 2. This is problem number 2, and problem number 3. X plus y plus z is equal to 6. 2x plus y plus 3z equal to 13. 5x plus 2y plus z equal to 12. 2x minus 3y minus 2z minus 10. We will follow the same job. We will write it in the matrix form as 1 1 1 6 2 1 3 13 5 2 1 12 and 2 minus 3 minus 2 10, and we start with our operations. So using this make these 3 zeros, ये जो आएगा using this make these 2 zeros, ये भी है make these 0, and when you perform make this 0, this should automatically turn out to be 0. So the last equation will be 0x1 plus 0x plus 0y plus 0z equal to 0, and then you take these 3 and back substitute, right? This is what is to be done. So this problem will be easier. Calculations are come here, right? Do it. nobody should sit idle असं आपल्याकडचं आहे, right? And everybody has to complete problems in sequence. So हा आधीचा मगाचा तुमचा झाला की then do this, then this, then this. Here is the same case, 3 unknowns, 5 equations. So we should get last 2 rows zeros completely. Okay, and then it will be 3 by 3. So efforts are more, but the solution will be fast. So the question goes like this: find rank of a matrix. The first one is 1, 2, minus 1, 3, 3, 4, 0, minus 1, minus 1, 0, minus 2, 7. And the second one is 2, 3, minus 1, 1, 1, minus 1, minus 2, minus 4, and it is minus 3, minus 1, minus 3, 2, and it is 6, 3, 0, minus 7. And the question is to find the rank. See the procedure, the method that we are going to call, or the form to which we will be reducing this particular matrix, is called as echelon form. There are 2-3 methods of finding rank, and in the question paper you will have to read it carefully. Your answer could be correct, rank is right, but the method is wrong. The first method, they say that by reducing it to find rank of a matrix by reducing it to echelon form. Next time they will say find the rank by reducing it to normal form, and the two forms are different. The answer remains same, right? And now here we will have as many as 4 3 by 3 determinants, right? Minors. So that is not possible for us to solve it. What we do over here is we will do the same job as we were doing yesterday, or we will perform only the row operations and try to convert the lower triangular elements to 0. Now see, this is the main diagonal, right? There are more number of columns. So we will try to make these 3 zeros and then decide what is the rank. What is the purpose? See, every determinant, let me have a determinant. If I am to evaluate it, one choice that you had was to take that element and multiply by the corresponding determinant, that is a cofactor of it. Correct? Evaluating a determinant, what is the procedure? The answer would have been A11 into A11, cofactor of it, plus A12 into A12, plus, because A12 comes out to be negative. Otherwise in our formula we have first element minus second plus third, so that is taking care of the sign of that particular cofactor. So it goes like this, right? But remember that if I reduce this determinant's lower triangle to 0, are you getting me? Then what will be the value of the determinant? It will be the product of the elements. Okay, what is value of this determinant? You can do this orally, right? So it is 1 into 4 into 3, minus 2 into 0 minus 0 plus 3 into 0 minus 0. So what happened? 1 into 4 into 3. So finding the higher order determinant is always reducing lower triangle to 0 and take the product of the diagonal elements. Many people forget this and we end up with a problem. And it is only the row operations, no column operation, though it is allowed in determinant, right? So now see, if this particular thing reduces to something like this, though with one extra column, then what will happen? I will have at least one product which is non-zero, that determinant, because there will be something here, right? Then I will have at least one which is non-zero, so rank will be 3. But by chance, while performing this task, I end up with getting this as zeros. Then I will have every minor of size 3 which will result in value 0, because the entire row turned out to be 0. Got it? So rank in this case will be 2. This is what we call it as a canonical form. So the task that we will perform over here is using this element, make these two zeros. Let it take care of itself. So it will be R2 minus 3 times R1 and R3 plus R1 will give us 1, 2 minus 1, 3. It is 0 minus 2 plus 3 minus 10. And when we add, it is 0, it is 2 minus 3, 10. First operation done. So first column below the diagonal is made 0. Then take the next diagonal element and make it 0 below it. So it will be simply R3 plus R2, and it will result in 1, 2 minus 1, 3, 0 minus 2, 3 minus 10, 0, 0, 0, 0, and we say that rank of this will be 2. What will be the formula? Row of A equal to number of rows minus number of 0 rows. So this is the 0 row. So rank of this will be 2. Job is done. Right? This is what we were doing yesterday, knowingly or unknowingly. We were actually finding the rank. It was rank of A and rank of AB. If it is same, the equations are consistent. But we were not knowing that word rank yesterday. Now here when we solve simultaneous equations, we will talk about that, saying that what is rank of A, what is rank of AB, and if they are same, the equations are consistent. If they are not same, they are not solvable. Remember that case we did yesterday where we had some zeros here and 4. Now rank of this A turned out to be 3. And this was our constant which was added to it, and it was 4. So rank of AB will be 4. Rank of A is 3. And equations are not consistent. But today we don't have anything like B. Our task is very simple. Given a matrix, reduce it to this form, lower triangle 0. Number of rows minus number of 0 rows is the rank. Right? And the size will go on increasing. Now it will be 4 by 4. Then there could be 5 by 6. There can be anything. Right? So make a note of this procedure. Now here while solving, I will probably take the first interchange 2 rows. So my task could be simple. It will be R12 and it will be 1 minus 1 minus 2 minus 4, 2, 3 minus 1, 1, minus 3 minus 1 minus 3, 2. 6, 3, 0, minus 7. And at a time we perform 3 operations, R2 minus twice R1, R3 plus 3 times R1, and R4 minus 6 times R1. So one step will make one column 0, second step these two 0, third step this will 0. So answer is achievable in 3 steps. Right? do it.
3x4 मॅट्रिक्स आहे ना, मग 4 होऊ शकते का रँक?
नाहीच होऊ शकत. रँक इज ऑलवेज मिनिमम ऑफ नंबर ऑफ रोज अँड नंबर ऑफ कॉलम्स. कारण 4x4 चा मायनॉरच होणार नाही ना याच्यात. रँक इज नॉट 4 बिकॉज वी डोंट हॅव 4x4 डिटर्मिनंट. So it is always minimum of number of rows and number of columns, right?
म्हणजे 1 वगैरे होऊ शकते.
हो.
3 पासून खालचं.
हां 3 होऊ शकते 2. इथे 2 रोज जर का 0 आले असत्या तर रँक वुड हॅव बीन 1. काय करणार त्याला? As reducing the matrix to the normal form and finding the rank. Okay, so the method, they say that find the rank of a matrix by reducing it to the normal form. One has to understand what is a normal form, and the normal form is one where the reduced matrix should be I. Now when can this be I? When if it is a square matrix and all the diagonal elements are 1. Or sometimes it can be I and 0, means we have got something like 1 0 0 0 0 0 1 0 0 0 0 0 0 0. Let me reduce it to this. Now is this form? No, because then it should be like this. This is I and 0. What this will be? It will be like I 0 0 0. This is I 0 0 0. We don't write those many zeros. That means there are 0 columns, there are 0 rows and I. And whatever is the order of this I is the rank. So this is 2 by 2. So rank of this will be 2. Its rank will be whatever is the size. इस I का जो भी size होगा, if it is 3 by 3, rank is 3. If it is 2 by 2, rank is 2. Now to make these elements upper triangle also 0, we will have to have some column operation that will be easier. So it will be alternate row operation as we were doing earlier, then a column operation, and then we proceed to the next one. So making first row or first column 0, making first row 0, and we proceed. That will be the procedure. Say it is 2 3 minus 1 minus 1. Oh, it was the one which we did earlier. We should do something different. Okay, it is 2 3 4 5. Array, this is simple. Okay, let me do the simpler one then. Then it is 4 5 6 7 and 9 10 11 12. I want to reduce it to the normal form. So it will be what? Because we don't want to do something like R2 minus 3 by 2 times R1. Then there will be total chaos, right? Then fraction is introduced and our calculations will increase. Instead, I see the difference as 1 and I perform something like, it can be R1 minus R2 directly. So it will be minus 1 minus 1 minus 1 minus 1 3 4 5 6 4 5 6 7 9 10 11 12, and then it will be R2 plus 3 times R1, R4 plus 4 times R1, R5 plus R2 R3 plus 4 times R1, and R4 plus 9 times R1, which will give us minus 1 minus 1 minus 1 minus 1 3 times. So it will be 0, it is 1, it is 2 and 3. 4 times it is 0, this will be 1, again 2, again 3, okay, and then it is 9 times, so 0, again 1, 2, 3. Oh, I've really chosen a simpler one, right? This is one step. Normally we used to perform this step, but we are required to make these elements also 0. So we will now directly go with C2 minus C1, C3 minus C1, C4 minus C1, and as the first column is already zeros, nothing will change except these 3 elements. Do you agree? Because these zeros will get subtracted, so there won't be any change. That's why this alternate step will be simpler. Only that row will affect, right? And then these elements will remain 1, 2, 3, 1, 2, 3, 1, 2, 3. But we want it as I, so one step increases. I will have to make this plus 1. So it will be, it can be R1 into minus 1. So it becomes 1, 0, 0, 0, 0, 0, 0, 1, 2, 3, 1, 2, 3, 1, 2, 3. And then it is R3 minus R2, R4 minus R2, giving us 1, 0, 0, 0, 0, 1, 2, 3, 0, 0, 0, 0, 0, 0, 0, 0. And then it will be C3 minus twice C1, C2, and C4 minus 3 times C2, and you will get only 1, 0, 0, 0, 0, 1, 0, 0, and 2 rows of 0. It will be in the form I2, 0, 0, 0, and so rank is 2. Got it? That is a normal form. So at the end, normal form, everybody will have the same values, right? You will have to follow this policy to multiply. Suppose ये minus 2 होता था, तो I would have said R1 by minus 2 or C1 by minus 2, whatever. Make it 1 and then proceed further. Okay? So, in another case, whatever problem we have solved earlier, over there we have got all the diagonal elements and upper triangular elements are there. So we can divide each row by that diagonal element, make it 1. See, I am telling you a policy to solve the problem. Understand it. This is one way where one row operation, one column operation. Second way will be, I will say straight away, say go up to the canonical form straight. Now in canonical form, lower triangle is already 0. Diagonal elements exist. Once diagonal elements exist, what will you do? Divide each row by that diagonal element. So diagonal elements will become 1. And using that one, just keep on subtracting from rest of the columns. First column, those will be 0, next will be 0, next will, you don't have to do any calculations only. वो सीधे ही 0 हो जाएंगे. It is difficult to agree, but this though you can solve, right? I will take one more example and show you. I have reached the canonical form like this: 2, 4, minus 1, 6, 0, minus 3, 1, 2, 0, 0, 4, 1. यहाँ तक तो हमने किया ही था पहले, right? Now I say that from here onwards, I will say R1 by 2, R2 by minus 3, and R3 by 4. We already know the answer, rank is 3, right? So now what will happen? It will be 1, 2, minus half, 3, 0, 1, minus 1 by 3, minus 2 by 3, 0, 0, 1, 1 by 4. Okay. Now it will be C2 minus twice C1, C3 plus half times C1, and C4 minus 3 times C1. This is 0, this is 0, this is 0. It won't affect any of the lower elements, right? Next step, what I will do, it will be C3 plus 1/3 C2 and C4 plus 2/3 C2. It will make these two zeros. And in the last step, I will perform C4 minus 1 by 4 times C3, and that will be 0. We are reducing it to normal form. right? But if you are okay with the first one, do that way or this way. Normally in the college they will suggest that do the first one, and even over there what happens is this step comes in between. बाकी क्या है? Once we reach this point, ये 2 हो गया, तो पहले हम इसे divide करेंगे and then we will perform this and then proceed. म्हणजे या मध्ये फक्त टाकायला लागतात steps. Either way answer is the right one. Okay, so I will give you that earlier problem and one problem more. किती देऊ? कॅल्क्युलेशनचा कंटाळा येतो ना आपल्याला, राईट? 1 or 2 प्रॉब्लेम मी 3 देतो, ट्राय 1 or 2, एखादा नंतर घरी बसल्या करा, राईट? सो द नेम इज, इट इज नॉर्मल फॉर्म and it is going to be either I, or it will be I0, or it can be I0, or it can be simply I000. It can be any of this form. Okay, it has to be identity. Yeah, first problem into it is 3 2 minus 1 5 5 1 4 minus 2 1 minus 4 11 minus 19. One, 2, 3, 0, 2, 4, 3, 2, 3, 2, 1, 3, 6, 8, 7, 5. And third is the same, 2, 3, 4, 5, 3, 4, 5, 6, 4, 5, 6, 7, 9, 10,